Welcome to section 1.1.3, which values are possible. Once again, it's going to talk about domain, range, and intercepts. So if you want to come up with a table of values, you can type those into your calculators. X and Y. So saying we already did that, we have -1, 0, 0, -5, 1, -8, 2, -9, 3, -8, 4, -5, 5, 0. So there's our values in the table. So we'll plot those points. So we're at -1, 0, 0, -5, 1, -8, 2, -9, -8, and then back to 0. We also have some other values. So what's going to happen is it's a parabola. That's the graph of a quadratic equation. It looks like a U. So there's our graph. Now our x-intercepts are at -1, 0 and +5, 0. Our y-intercept is at 0, -5. Now, if you look at those x-intercepts, see how we have the x plus 1 and the x minus 5? If we were to solve those, that x plus 1 equals 0 and x minus 5 equals 0, we'd get x equals -1 and x equals 5. That form of a quadratic is called intercept form. It actually gives us our intercepts in that form, and that's what's beneficial about it. Now, our vertex, that lowest point on a quadratic, on that parabola, is at 2, -9. Our domain is all real numbers, and that's the symbol, once again, for all real numbers. And our range, it starts at -9 and goes all the way up to positive infinity. So y is greater than or equal to -9. And that's our first graph. Graph number 2, this is what's called vertex form. And we'll be talking about this as the year progresses as well. But for right now, just type it in your calculator and get your table. So for our x, we're going to have 2, 11, 3, 6, 4, 3, 5, 2, 6, 3, 7, 6, 8, 11. So we're at +2, we're at 11, we're at 3, 6, we're at 4, 3, 5, 2, 6, 3, back up to 6, and 11. So our parabola looks like this. So now, our x-intercept. This never crossed the x-axis, so there is none. Our y-intercept, now I'm going to talk a little bit about solving for this algebraically. So for our y-intercept, for the y-intercept, x is always 0. So y equals 0 minus 5 squared plus 2. So y equals -5 squared plus 2. -5 squared is 25. And 25 plus 2 is 27, so y equals 27. So our y-intercept is at 0, 27. If we looked at our table and kept going up and up and up, we would see that 0, 27 is on our graph. Our domain, we can use any value we want to for x, so it's all real numbers. Our range, our lowest point is 2, so y is greater than or equal to 2. And for good measure, our vertex is located at the point 5, 2. Going to the next page. Problem number 3. We want to sketch a graph that has the following characteristics. has to have a domain between -3 and 10 for x, and a range between -4 and 6. So what I'm going to do is I'm going to draw a little bit of a box so that our graph fits into it. I want my x values to be between -3 and 10. And I want my y values to be between -4 and 6. So our graph is going to need to fit inside of this box. That's all we're being told. So that's the only thing we have to meet. We're not being told anything else. So I can start here anywhere as long as I touch this line. So I'm going to put a solid dot there. I'm just going to have it go up, reach that 6, come back down, reach the -4, and then just back up again. And that meets the requirements for this graph. There's more than one correct answer. You could have pretty much whatever you want to, is making sure that you touch each of those lines. Try another one. The domain is all real numbers, and the range is y is greater than or equal to -2. So for all real numbers, we're not going to have anything to the left or the right because we need to go all the way left and all the way right. All we have to do is make sure we don't go below this line. So what I could do is I can put a dot anywhere here. So I'll put it right there just because I feel like it. And I'm just going to draw a parabola. Once again, that's not the only correct answer. That's just one of the correct answers. There's more than one correct answer there. Now, let's talk about solving a system of equations. A little bit of review from Algebra 1 again. So the way this is written, here's my two equations. You see how this second equation has y equals already? What I want to do is I want to use the substitution method to solve this system. So wherever I see y in the top equation, I'm going to substitute 2x plus 4. So I have 3x plus 2y. So instead of writing y, I'm going to put 2x plus 4. I'm going to substitute that in place, equals 1. So I get 3x plus, distribute the 2, 4x plus 8 equals 1. Combine, 7x plus 8 equals 1. Subtract 8, 7x equals -7. Divide both sides by 7, x equals -1. That's x, but I still need to find y. So I'm going to use the bottom equation, y equals 2 times -1 plus 4. Y equals -2 plus 4, so y equals 2. Remember, when we're solving a system of equations, we're finding out where the point of intersection of these two lines is. So our point of intersection on the graph is at -1, 2. And there is our answer. Now, the way problem number 6 is written, this is a good candidate for what's called the elimination method. That's where we have the x's lined up in a column, the y's, equals, and the constants. So what I need to do is I need to get opposites, the same number with different signs. So you can pick a variable to get opposites for. Just looking at it, I'm going to pick x's because why not? So through multiplication, if you think about the multiples of 3, we have 3, 6, 9, and the multiples of 2, 2, 4, 6, 8, 10, and it keeps going. I want to find the lowest common multiple, and that is 6. That's when they're both going to be the same. So to get 3x to become a 6x, I'm going to multiply the entire top equation by 2. So that would give me a 6x plus 14y equals -2. Now I need the bottom equation to have a -6x. I'm going to multiply by -3. That gives me a -6x minus 9y equals -18. And you can see I have opposites for the x's. So I'm going to add those two equations together. And when I do that, the 6x and the -6x cancel each other out. They're eliminated. So now 14y minus 9y is 5y. -2 plus -18 is -20. Now I can solve for y by dividing both sides by 5, and I get y equals -4. Still need to find x, and we can do that by going back into either one of the original equations. I'm going to use the top one. Doesn't matter. 3x plus 7 times negative 4 equals negative 1. 3x minus 28 equals negative 1. Add 28 to both sides. 3x equals 27. Divide both sides by 3. X equals 9. So again, that solution is that point of intersection, 9, negative 4. That's where if we graphed that these two lines would intersect. Going to the next page. We can use the calculator to actually solve these. So to do that, we need to get it into the equation y equals. So I'm going to rewrite the top equation, 5x minus y equals 35. I need to isolate my y. I'm going to get it in slope-intercept form. Subtract 5x from both sides. Negative y equals negative 5x plus 35. And then divide everything by negative 1. And I get y equals 5x minus 35. I'm going to rewrite the bottom equation. 3x plus y equals negative 3. Subtract 3x from both sides. Y equals negative 3x minus 3. Now, we can use the Texas Instruments to show how to solve this on the calculator now. So on the TI, y equals, and then it's going to be 5x minus 35. And now to get to y2, you can either use the arrow key down or hit enter. And that's going to be negative 3x, so make sure you use the negative sign. Negative 3x minus 3. Hit graph. We're seeing part of the graph. We'd have to change the window to see more, but we actually don't even need to do that. We can look at the table. And our goal here, as you can see, our values for x and our values for y in both graphs. We want to find out which value of x gives us the same values for y. So let's go into that direction where the positives are, because that looked like where the graphs were going to intersect when we looked at it. And as we see, negative 4 has outputs of negative 15. So there is our solution. So our solution is negative 4. I'm sorry, that's positive 4, negative 15. And we could check algebraically by substituting our values into both. So y is negative 15 equals 5 times 4 minus 35. Negative 15 equals 20 minus 35. Negative 15 equals negative 15. That's good, but it needs to work for both. Negative 15 equals negative 3 times 4 minus 3. Negative 15 equals negative 12 minus 3. Negative 15 equals negative 15. And that is a good solution. So that's where those two lines intersect. You could do the same on Desmos as well. Number 8, we're going to graph the following and find the intercepts. So you'd want to use your graphing calculator. So you get y equals 1 over x minus 4. So the way that would look, y equals, I'm going to clear both of those out. It's 1 divided by x, because remember, fractions represent division, and then minus 4. And there is our graph. Now, if we go back, you can look at the table as well to get the values. If we look at this, you see we're dividing by x. The only number we can't divide by is 0. So x can never equal 0. So for our table, here's just a couple of values. -2, -4.5, -1 is -5. If we put a 0 in there, we don't get an output. It says an error. We can't divide by 0. So when we have 1, we're at -3. When x is 2, we're at -3.5. We're at -3. If you keep looking further and further in that table, you'll see that the values of y, as we get bigger and bigger in the x, they're going to get closer and closer to -4, but never quite reach -4. And the graph on that side is going to look like this. Now, if you get in the more negative direction, as you keep putting more and more values in that negative value for x, you'll never get to -4. That's what our graph is going to look like. Now, looking at this, our x-intercept, that's the value of x that makes y equal to 0. We don't know exactly where that is, so let's find it algebraically. So 0 equals 1 over x minus 4. Add 4 to both sides, so 4 equals 1 over x, and we could put 4 over 1 to make it a fraction. Now to solve this, it's a proportion. So what we can do is we can cross multiply. 4x equals 1, divide by 4, x equals 1/4. So our x-intercept is at 1/4, 0. Our y-intercept, we never cross the y-axis. So for our y-intercept, there is none. Problem number 9 looks similar, but it's slightly different. You can see where the 4 is different. The 4 in number 9 is in the denominator, whereas in number 8 it is not. So once again, let's go to our calculator. And let's go to y equals. So y equals, now to write this properly, it's 1 divided by, now we're dividing by the whole denominator, so we need our grouping symbol. So we're going to put parentheses, x minus 4, and close our parentheses. That way we make sure that it stays in the right position. And we can graph that. And you can see the graph looks different because it's a different equation. So now for this one, if you look, x can never equal 4. So if we have our table, and you can get the table right from the calculator, 0, -0.25, 2, -0.5, 3, -1, 5, 1, 6.5, 8 is 0.25. Remember, we can't use 4. That's why there's that little gap there, because it would give us undefined, give us division by 0. -0.25. 2, we're at -5. 3, we're at -1. There's nothing happening at 4. 5, we're at 1. Then we're at 0.5, 0.25. As we keep going in that larger value for x, we're never going to quite reach 0. So the graph, and we're never going to get to 4 as an input. So it's going to look like this. As we keep getting in the negative values for x, we're never going to quite get to 0. We're getting really close, but never quite reach it. And we're never going to touch -4. So this is what the shape of the graph is going to look like. So our x-intercept, we can actually see, we already have it. Our x-intercept is at 0 and -0.25. And our y-intercept, it never crossed the y-axis, so there is none. We'll be talking about those graphs more in future chapters and in future sections. That's it for section 1.1.3. Thank you.